नहीं नहीं, ये एक्चुअली क्लास है S4 में, तो वहाँ मल्टीमीडिया नहीं मिला, तो आज मल्टीमीडिया चाहिए था, इसलिए हम देखेंगे कौन सी क्लास अवेलेबल है, लेकिन यहाँ पर भी मल्टीमीडिया नहीं चाहिए। थैंक यू। ETABS यही मॉडल है ना, हो रहा है, रिकॉर्ड हो रहा है जी, रिकॉर्ड ठीक है। Okay, please pay attention. Let's get started. We shall be covering the earthquake options and wind options today, and also I will try if we can import the grids from AutoCAD. Please open up your model. ठीक है, अच्छा ये ऑन हो गया, ठीक है, ये थैंक यू। Okay. Okay, now let's define the earthquake. We shall define the earthquake using UBC 97, which is Uniform Building Code, Code 1997. After UBC, we shall use UBC 97. The latest code is, I think, IBC. IBC is International Building Code. Okay. You can. I think you will be studying this earthquake thing in structural engineering. So our objective here is to learn the commands of the software. We shall not go into the theory of this, but I will tell you how you can incorporate or how you can introduce the earthquake forces, and maybe you will study IBC in your structural engineering class. So I shall be covering the relatively more popular Uniform Building Code. Actually, Uniform Building Code, I think in year 2000 or somewhere, they changed it to International Building Code. They changed the name from UBC to IBC. Okay, for this is our previous model. I will unlock the model, okay, and define the earthquake forces. But before I define the earthquake forces, I would like to increase my number of stories. Right now I have only one story structure, so I will go to edit, and because on more stories you can better visualize the earthquake displacement. Insert story. Okay, you want to add more stories, go to edit story data and insert stories. So edit, insert story. Now here you can tell how many stories you want to add and what is the story height and what is the name of the story. Let's keep the name as default. This is story height. Our units are in inches. 144 means 12 feet. Number of stories. Okay, we can add like 12 stories. We are adding 12 stories. Insert above story level. Above which story you want to add, and in this case we only have one story, so definitely it will be added above story number 1. For example, you have 5 stories, okay, and you want to add a story above story number 3, okay, then you can use this option. And it says replicate new story from existing story or none. Means the stories you want to add, are they exactly same as your one of the stories you have already defined, or they are different? So if you pick this option, then all the definitions, I mean the member sizes, the material and the loading and the dimension, everything will be replicated in the next stories, in all the stories you are adding. It means that you will not have to add all these loads or assign members. Sometimes you will see that in high-rise buildings, some of the stories have similar use and similar patterns. For example, the typical pattern of high-rise story building is that the first couple of floors are for shopping, right? 3-4 floors are for shopping, and then offices, couple of floors are for offices, and the remaining floors are used as residential apartments. So you can find similar stories in a building, so that's why it's helpful to use this replicate option. Okay, so I will replicate it from my story 1. This is story 1, so all my stories will be exactly same in terms of loading and definitions. Just press OK. Okay, so now your structure is a 13-story structure, okay, and all the stories are exactly same as the first one. If you look at the elevation, now it looks like a reasonable size building, right? And you can add as many stories as you want. There is no such limit, and it only depends on your machine, how good your machine is. I mean, it will take less time to analyze if your story is if your machine is good machine. Let me change this column. You remember that this column, this one, was defined as a beam by mistake, so I just picked this one, okay, and assign it column 15 by 15, okay, and change the support at the base to fix. Okay, now I go to earthquake, define static load cases, and here you have this quake. We shall apply the earthquake in 2 directions, in X direction and in Y direction. Okay, we shall define 2 earthquakes. One will be EQX and EQY. Although earthquake can hit the building from any direction, right? You can't predict the direction of waves, and of course in our analysis we cannot incorporate all of them, but generally engineers consider these 2 directions, right? So I will name this EQX, and this is the type quick, this is the name, and from here I will pick my code. Okay, right here UBC 97. Okay, but I can right here you also find IBC 2000, IBC 2003, IBC 2006. On your notes you can write down that you have to explore about IBC 2006, and I think your structural engineering course would be covering it. I haven't seen it recently, so I will go for UBC 97. So you have to pick the code, you have to name it, and you have to pick the type, and then what you do, add new load. When you add new load, EQX will be added. Then that's not enough, you have to come here, modify lateral load, modify lateral load, hit this button and this panel will appear. Just by giving the name EQX doesn't make it an X direction earthquake. You have to pick this option, which is by default picked already. This is X direction earthquake right here. Okay. Now the terminology used here is new for you because you have not studied this, and I shall not be discussing these technically what these are. I will just tell you briefly about them. For example, this is time period. This time period for concrete is 0.035. So for concrete you plug 0.035, I think. Let me see. What you need to do is go to Google and find UBC 97 earthquake loading. You will come up with couple of pages from the code where it defines all these parameters. Okay, but for concrete, I think, I'm not sure if this is 0.035 or 0.03, but let's keep it 0.03. This is time period. Okay, then this is story range, which means that from which story to which story you want to apply the earthquake. Of course we want to apply the earthquake from the base to the last story. This is our last story. So from the base to the last story, we want that all the structure, all the story be applied with the earthquake. Then the next factor is overstrength factor, capital R. R can be 8.5 for special moment resisting frame. It's 5.5 for intermediate moment resisting frame, and this value is 3.5 for ordinary moment resisting frame. Okay, I can just tell you that the regions where which are prone to high magnitude earthquakes, in those regions we design special movement resisting frames. For example, if you want to design a building for Balakot or Mansehra, areas like that, then you shall design a special movement resisting frame. For that you have special requirement of detailing from ACI code, and there you will use 8.5. For moderate earthquake regions like Lahore or most of the areas in Punjab, you design intermediate movement resisting frame. That frame has less magnitude of steel. there you use 5.5. And for the regions where you don't have any danger of earthquake, for example, you are designing for Bhavalpur, right, or other regions in the southern Punjab or interior Sindh where you don't expect the earthquake will appear. There you design ordinary moment resisting frame. So your value is 3.5. So I will keep this 5.5, okay, intermediate, assuming we are in Lahore. The building is in Lahore. Then the next thing is seismic coefficients. These coefficients, for example, soil profile type. When you drop this, you see different abbreviations: SA, SB, SC, SD, SE, right? Do you remember ASHTO soil classification?
Yes, sir.
ML, CL, something like that. Okay. This is not that classification. This is different from that. This SA, SB, SC, this classification is particularly belongs to UBC 97 code. It is not the geotechnical classification of soil. Okay. But of course, these represent different type of soils. For example, in Lahore, most of the soil when you dig in Lahore, most of the time you will find silty clay. Okay, most of the time you will find silty clay. Okay, so for Lahore, I think it's either SC or SD. As I said that you download the guideline for UBC for earthquake loading. There are a couple of pages. In those pages you will find a table where everything is defined. But you can also find this in help of ETABS, I think. So I will assume that my soil is SC, which is I think for Lahore it's either SC or SD. Okay, I'm using SC. I'm forgetting the right one exactly. Why it is important? Why soil type is important? Because earthquake waves travel in the soil. If it is rock, the waves travel in a different way versus if it is a soft soil or loose sand, then earthquake would travel in a different way. Okay, so that's why it is important to define the type of the soil, and the UBC 97 appropriately consider a factor for the type of soil. Then the most important thing, that is seismic zone factors. How many factors you see? 1, 2, 3, 4, 5. Okay, you see 5 factors. These 5 factors means there are 5 zones. 5 zones. Okay. What are those zones? Zone 1, 2A, 2B, 3 and 4. These are 5 zones. Okay. Lahore is in zone 2A. So we are like moderate earthquake zone, and zone 4 is the northern part of the country, Balakot and other parts. They are in zone 4. Okay. When there was an earthquake in 2005, after that Islamabad was put in zone 3, but later on it was again moved back to zone 2. But anyhow, we are in zone 2A. Now the factor here, first factor 0.075, this factor is for zone 1. 0.15 is for zone 2A, 0.2 2B, then 0.3 zone 3, and 0.4 is for zone 4. Okay, this 0.1, 5, 0.2, 0.3 or 0.4 is actually multiple of G. 0.4 means that an earthquake with an acceleration of 0.4 times G can hit the area. What is the value of G? It's 9.8 meter per second square. So if you multiply that with 0.4, it's approximately 4. So we can say if you are in zone 4, so an earthquake with acceleration of 4 meter per second square can hit the area. Okay, so these are actually multiples of G. Okay, it's actually 0.075 G, then zone 2A is 0.15 G, and 0.2 G, 0.3 G, and 0.4 G. Okay, so I will pick 0.15. Okay, and the last thing is importance factor. Again, in UBC 97 you will find importance factor. Importance factor is dependent on the use of the building. If the building is an essential facility, for example, if this is a hospital, or if it is a fire brigade building, okay, which is or any other building which is related to the survival and rescue, that has more importance over a shopping center or any other building which is not related to emergency condition. Okay, so regular buildings have importance factor of 1, and essential facilities have importance factor of more than 1, maybe 1.2, maybe 1.3. Again, UBC 97 will provide you a table where you can find it. For an ordinary building or for an educational building, you can keep the importance factor equal to 1. So I will leave it as 1. So that's how you define earthquake. That's it. But this is an X direction earthquake. You also need to define a Y direction earthquake. Okay, so I change the name to Y and add new load. So now I have an earthquake X and earthquake Y. But for earthquake Y, I have to go back to this modify lateral loads and see what I need to change. I need to change the direction. It's Y direction, but other values are by default same. I mean, it picked the value from the previous definition. So that's how you define earthquake. Okay, you can also define wind. This is wind. Again, you can define wind based on UBC 97. Add new load and then modify lateral load. Exposure and pressure coefficient, leave it like this. Exposure from rigid diaphragm, extent in rigid diaphragms, maybe you need to review this, but I can't cover it right now. Yes, here you can define the angle, at which angle the wind is hitting the structure. Okay, but I remember that if you have a 0 degree angle, I think this is an angle with x-axis. So 0 degree angle means the wind is parallel to x-axis. But make it certain later on, or maybe we will see the analysis result. If it is parallel to x-axis, definitely we will see some displacement. Wind coefficient, windward coefficient. Okay, now you will go back to your steel structure lab In steel structure lab, you learned how to define the coefficients for windward and leeward side. Okay, for windward side, and it depends on the height, maybe your exposure condition. By default, it is 0.8 for windward, and leeward it is 0.5. You can read the literature from steel structure and can appropriately give these factors based on the type of building you are modeling. So I will leave 0.8 and 0.5 unchanged. Okay, exposure height. From which story to which story you want to apply the earthquake or wind forces. Okay. If you have basements, for example, if you have 3 basements for parking, then there is no point in applying wind forces on the basement, right? Because basement, of course, is under the ground. So what you can do is, you can skip the basement and start from the ground floor. From ground floor to the top floor, you can apply the wind forces. Okay. But right now we don't have the basement, so we say, okay, from the base to the top we have to have wind. And also you can include a parapet height. You know, we have parapet all the time. So let's assume we have a parapet of 3 feet, 36 inches. So you can include that length as well. Now wind speed. This is in miles per hour. No matter what units you have to plug the wind speed in miles per hour. Generally in Lahore we design for 100 to 110 miles per hour. Okay, 100. You see all these communication towers all around the city. They used to be designed at 100 miles per hour. But I think back in 2005 or 6, couple of towers failed. I mean, one was in Kent that came down, and one at another place. So I think after that, some of the designers used 110 miles per hour. But when I saw that the one which failed, that didn't fail because of the wind. That failed because the connection to the top slab was not very good. But anyhow, you know, you have to properly anchor the tower to the slab. It's a rooftop, so that anchorage was very small, maybe 2 inches. So that was actually designed to fall. So it fell down. So we can keep it 100 miles per hour. Exposure type. Exposure means it is related to the location of the building. For example, if the building is on the ocean and you have open sea, then the wind will hit the structure uninterrupted, right? But if, as opposed to this, if your building is in downtown area where it is, you know, so many other buildings in the surrounding, then the wind effect will be different. Wind has hindrance, right? It can't hit the structure with the same intensity as it does in open area. Okay. So again, you have to go back to your steel book and see what is B, C, and D. I think B is the mild one, okay, and C in the middle, and D is I think like an open C thing. So I keep it B. And then importance factor. Again, it's the same thing. If you have an essential facility, importance factor is more than 1, otherwise it's 1. Press OK, and that's how you define. You can define wind in X direction as well as in Y direction. You can define wind at any angle. You can say, okay, 45 degrees from the x-axis, so wind will hit the structure inclined, right? So there is no limit, but it is just your judgment, right? But remember that for medium rise buildings, wind is generally not critical. If you have a building of 10 stories, I don't think that wind would govern the design. Yes, earthquake would govern the design, but wind generally does not govern the design. Yes, for the cities where you have hurricane, some of the cities in central part of United States, some of the states in US like Oklahoma, Texas, part of the Texas, and maybe Arkansas or something like that. There you have tornadoes. You know tornadoes? Tornadoes. Tornadoes hit the structure, and the structure can be in a very bad shape or completely wiped out. So in that case, you have to be careful about the wind. But in other cases, for a country like us, it's not that challenging. Yes, if you are designing a building in Karachi, right on the ocean, you have to worry about the wind. Sorry. What happened, gentlemen? Nothing happened. Okay. No, you just defined the wind, not the components. But you set the angle. It's parallel to x-axis, y-axis, or it's 45-degree angle, like that. Okay, with this we finish our definition of the loads and press OK. Let me analyze it. While the structure is getting analyzed, I go to AutoCAD. Sorry? Okay, you don't have to assign the wind or earthquake forces. You just have to define. You define the earthquake and wind. The software automatically applies it on the structure. It is different from the live load or dead load, which you have to define first and assign as the next step. Okay, so you only define earthquake and wind, and that's all. Yes, I think it's B. But even in the city, it may be different. For example, if you are constructing near the airport, okay, it's different exposure. If you are constructing in Gawal Mandi, it's different, you know, thickly populated area. Okay. AutoCAD. I'm not very good at AutoCAD. I when I was student, AutoCAD was not part of our syllabus. No, that was not 1960. That was little later, but later. No. Anyhow, so after I graduate, I couldn't convince myself to learn AutoCAD because I thought that it's not my job to draft, you know. Anyhow, AutoCAD is a very useful tool. Why we are using it? Because in relation to the modeling on ETABS, nowadays structures are not of very regular shape. They have all kind of curves, angles, you know, and crazy shapes. So it is difficult to draw the grid lines according to the true shape of the building. Okay, it is laborious, and also you will make some approximations. Fine. So the better way is that you draw the grids in AutoCAD according to whatever the shape is, and then import those grids in ETABS. Okay. So for that purpose, we have to or we should first of all introduce a layer which is exclusively for plotting the grid lines. Okay, let me find out where I can add the layer. Is it where I can? No, it's not. I want to add the layer, so I go to insert. I may need your help. It's long time I did that. I want to add one new layer. Okay, where is the button for the layer? Right here. You're right. Okay. Okay, we find it. Yes, layer properties manager. Right here, add new layer. So you add new layer and name this layer. Let me see if I can rename this layer. Yes, name this layer as ETABS grids. Okay, press OK. Very good. Okay, now I want to display this layer. Where is this layer? This one? Okay, right here. I have to check it. Okay, now I am in ETABS grid layer, right? So what I will do, it will stay in this layer. Okay, this is a line. What you have to do is, by using these lines, by drawing these lines, you have to locate every intersection where you may have a column. Okay, so I will just randomly draw the line. For example, I am just targeting my wall. Okay, this is the line. Escape. How can I get rid of this? Okay. Okay, this line locates this wall. Then another line. Oh, sorry. Okay, this line. Okay, now tell me. Space? Okay, very nice. So this line. Third line. I want to stay with the line. I mean, you know, I don't want to go back again and press this button. Space and oh, come on. Okay, let me do it my way. Okay, you see, I have drawn 4 lines. 1, 2, 3, 4 lines vertical, which are locating some of my walls. I have drawn 2 horizontal lines, one this one, another this one, and this is also a wall, so I will draw another line somewhere here. Okay, although it's not picking up exactly, but just I just want to show you how to do it. and this is another line or another wall, so I will draw this line as well. Okay, and the last wall is this one. Okay, so I have tried to locate all the walls and intersections. So you can, on your architectural plan, you can locate all the walls or columns. I mean, all the intersection, I should say. Save this. Okay. Now I save it as a DXF file. It has different versions, AutoCAD 2007, AutoCAD 2004, AutoCAD 2000. Let me do it AutoCAD 2004. Actually, maybe some of the versions may not be compatible with our ETABS. Okay, you know, it depends which one is earlier and which one is later. So I am to be on safer side, saving it as 2004. Okay, I am naming the file ETABS grids. Okay, and I am saving it on the desktop. Is this my folder, ETABS? Okay, save it. Fine. That's it. Now I'll go to ETABS. Oh, it's still doing analysis. You know, I actually added so many stories. Okay, I will go ahead and cancel this analysis. Okay, I'll open this again. Okay, file, import DXF file of architectural grid. There are other things which you can import as DXF, for example floor plan. It includes the walls. I think you don't need a wall. It can also include a 3D model, but I think you should make your own model because sometimes it makes mistakes. So you choose the option DXF file of architectural grid. Click on this and it will take you to your hard drive, and you go to the correct, yes, right here is our ETABS grids. Okay, when you open this, it asks you that in that file which layer you want to import. You can import more than one layer, of course, but I will just pick my own layer of ETABS grid. Right? So pick your layer, ETABS grid, global up is Z direction, ignore lines shorter than this, units are kip inch, all that, fine. Okay, very nice. What do you get? You get a grid. You get those grid lines which you plotted there. And I'm not sure if you can clearly see all of them. Let me change the colors. The grid lines are gray. Let me make them white so that you can see them. Now, can you see them? Why it's not changing? I don't know why it's not changing. Can you switch off this light? कोई बात नहीं, बैठो. You can change the background maybe. Yes, that's better. So you see all those grid lines which we plotted there, and they are available here. So you can use these grid lines to draw your members the way you want. What's happening? Actually, the beams I'm plotting are actually yellow. So when I plot it, it goes away. No, you just don't have to do that. That's better. Now you see it is red. Okay. It added 4 stories, so I'm just deleting them. Okay, one thing is very important, and that is about units. You have to be careful about the units. For example, right here, the distance which it is showing right now, look at the coordinates. The coordinate it is showing right now, it are in thousands of feet, 22,000 and 16,000. I don't know what is the understanding of the software. For example, the origin is right there in the corner, okay, in the software, the global axis. ETABS, when import the grids, it places it randomly somewhere, okay. So what you can do, you can move your grid lines, select all the grid lines, and then go to edit and move the grid lines close to your origin, okay. That's just a cosmetic thing, but it is easier for you to handle when your model has smaller grid values. But I think what my objective was that I show you how you can actually work with the software to import the grids from AutoCAD. So this is same procedure no matter what type of building you have, how complex it is. You just have to introduce a layer in ETABS, draw the grid lines, save it as DXF file, and import it here. That's all. That's all. So it's okay. Let me go back to my original model now. I'm just deleting some of the stories, and now my structure is a 4-story structure. Let me see if we can analyze it. I just want to show you how you can generate the report. Your structure? Okay. Good. Okay, the computer actually is slow. It depends on the memory and processor. Yeah, right. Is this laptop like a complete laptop, or there's something? Can somebody give me the laptop where I can see? एनालाइज हो गया, हो रहा है, ये भी हो ही रहा है. Yes, we are almost there. Get up with your laptop. Okay, I think it's done as well. Not here. There. Okay. Okay. The structure is no. Just keep standing. Yeah. Okay. The structure has been analyzed, and it looks similar to our previous analysis. This is deformed shape under the live load. So we can go ahead and see the deformed shape under the earthquake, EQX. Okay, let me show you the elevation. Fine. So here you see deformed shape under the earthquake, and you clearly see lateral displacement. Okay, this is deformed shape due to earthquake in X direction. That's why you see deformation parallel to X-axis. Okay. Similarly, you can display the deformed shape due to earthquake Y. Okay, let me show you the deformed shape in earthquake Y, and you will see that it moves in the perpendicular direction like this. That's Y direction, you know. No, you can't see both of them at the same time, you know. No, that's not logical. So you can only see deformed shape for one loading at one time. So this is deformed shape for earthquake Y. In two-dimensional Ali, the door is open. I mean, in case you would like to go out. Okay. Deformed shape in Y direction. Then for that purpose, you will have to see elevation A. Like this. Okay. So you see clear deformation. And you click on this joint, and you will see deformation. If you read this deformation, the delta X is at 4th place, 0.0001, and delta Z is again 0.00023. But if you look at delta Y, the value is 0.06. So you see that delta Y is almost 100 times or maybe more than delta X and delta Z, because this is Y direction earthquake. Okay, you will see a similar thing, I mean similar difference in magnitude if you pick the X direction. For that you have to go to elevation number 1. Okay, you pick this, and now you see X direction is 0.06 and delta Y and delta Z are very small values. Okay. And you should also see animation. When you see animation, you can switch this thing off. It is important to see the animation, because as I told you before, sometimes when the connection is not proper between the members, then at the time of animation it actually shows that the member is flying loose in the air. Okay? Why don't you go there? My tube light, you know. Okay. I think this will take some time before we can show you. But what you can see on your screens is deformed shape in earthquake Y and earthquake Z. And I will also show you the combinations. I said before that when you have only live load and dead loads, then there are only two combinations. What was the combination? It was decon 1 and decon 2. Decon 1 is 1.4 times dead and decon 2 is 1.2 and 1.6. Now you will see that you have more than 10 load combinations because you have earthquake in X and Y direction as well as you have wind. So some of the load combinations involve dead load, live load and earthquake. Some of them would involve dead, live and wind. For example, if we have earthquake right now, then the building has dead load and we are all live loads and the earthquake hits the building. So it represents that situation, that when the building is occupied and it is hit by an earthquake. For example, if the building is under construction and it is not in use, then in that situation it's only dead load and earthquake. Or for example, this department in the evening there is no significant live load, then at that time it's earthquake plus the dead load, yes, including part of the live load, which is furniture, of course. So I will go to design, concrete frame design, and select design combination. Okay, so already it has so many combinations. Oh wow, we have 39 combinations. We don't have to worry about more combinations because it's the job of the software that it picks the highest values of moments and shears and axial forces out of all these combinations and design for the respective force. I just want to show you cancel this. What I am wondering is why we don't have our basic combinations. I think it named it differently. Let me see what is decon 20. Okay, I don't know why, but it has named it differently. Maybe because I had already defined decon 1 and decon 2, so it didn't want to give a name. No, I defined another one. I said, but anyhow, look at this. Decon 20 is what? It's actually the very first combination. 1.4 times dead. Okay, decon 21 is 1.2 dead and 1.6 live. And decon 22 is, yes, look at this. It's 1.2 times dead, 1 live, 1.2 dead, 1.2 dead and 1.6 wind. Let me pick another one, decon 28. Okay, this involves earthquake. Earthquake is 1, floor finishes is 1.4, I mean dead load, and live load is also 1. So I'm not sure why it has changed the names. It generally doesn't happen. Okay, this is earthquake EQY -1. What does this -1 means? This -1 means that this particular load combination involves the earthquake which is opposite to Y direction. We introduce EQX and EQY. The software itself consider the earthquake in the opposite directions. For example, EQX is from left to right. Okay. EQ minus X is what? From right to left. As we said that earthquake can appear from any direction, we can't predict it. So just to cover more cases, the software intelligently takes the decision and also apply the earthquake in the opposite directions, opposite to those directions which we have already defined. Okay. Okay. I think I would like to stop here. There are many things related to the software which you want to know, and during the course of the semester you can explore it and we can talk about them more. I will be discussing it maybe later on sometime. In the meantime, you can go to the website of CSI and find Watch and Learn. Watch and Learn, in the Watch and Learn tab, you will find video tutorials of SAP 2000, of ETABS, SAFE, and maybe some other CSI bridge and all that. So you can, and those videos are from the basic to the advanced level. So with the knowledge you have here in the class, plus Watch and Learn, you can definitely enhance your skill on the software. Okay? Everybody understand that? What should we do with this gentleman? No? What? Which we are correct. Okay. I think he deserves some kind of punishment. That's not a punishment. He needs a physical punishment. Okay. So, sorry? Push up? No. Something else. Okay, so what should we do with you? Suggest some kind of punishment. That's not punishment. I missed it, sorry. Okay, let me mark the attendance. Maybe I have a better idea after the event. Okay, give me a pen. Okay, roll number 61, 62, 63, 64, 65, 67, 68, 69, 70, 14, 71, 72, 73, 74, चलो बात 75, 76, 77, 78. You can put your lap. 80.
Yes, sir.
81, 82, 83, 84, 85, 86, 87, 88,